Hello everyone. In this video, I'm going to talk about pH and pOH by reviewing some practice problems. First, I'm going to talk about pH. As you may remember that pH is a number with no unit. This is a unitless number that is going to indicate we have acid or base. We have acidic or basic solution. Before talking about pH, I'm going to remind you pH stands on power of hydrogen, and this is the one of the concept we may find some application for that in the chemistry labs. But for the pOH, we find only in the theory, and we do not have any instrument to measure pOH. But pH is going to use as a most commonly used indicator in the chemistry classes. It's going to indicate acidic and basic. So I'm going to talk about the pH by a range of number. pH is going to change from 0 to 14. So if we have this range of number 0 through 14, we are going to talk about two types of compounds, acids and bases. So I have to divide it by 2. So divide by 2 means 7. Based on the convention, pH between 0 through 7, we call that acid, and we are going to represent acidic solution. And for the pH, we have for greater than 7 and smaller than 14, we call that base. So we are going to talk about basic solution. I'm sure you can easily say that if we have pH exactly 7, we are going to talk about neutral solution. In advanced chemistry classes, and when we are going to talk about pH, we are going to change the range of the neutral solution. A little less than 7 and a little bit higher than 7 can be considered as a neutral solution. But for this level of our class, we assume that pH 7 is going to be the neutral solution. It belongs to the neutral solution. And if we have pH less than 7, we call that acidic, and pH greater than 7, we call that basic. I'm sure you have this understanding when we are going to talk about two different solutions like this solution A with the pH 3, and if we have another solution B, pH is 5, both are representing this is a 3 and this is a 5. Both are representing acidic solution. But if we are going to know which one is more acidic, we are going to say lower pH makes more acidic. More acidic. And if we are going to talk about the basic, absolutely higher pH make more basic solution. More basic solution. Let me give it you the example for this one as well. Assume that we have pH, we have A prime and B prime. So we have pH 9 and we have another one pH 11. So pH 9 belongs to the basic solution and 11 belongs to the basic solution. Higher pH, it represents we have more basic solution. Right now, I'm going to ask you please pay attention to the numbers I reported here. It looks pH can be reported by 1 digit, by decimal places, and so on. So I'm going to work on the equation for pH. As a first application for pH, we may determine acidic and basic solution. As a second application, we are going to determine amount of acids. So pH has this equation, negative log H3O plus. H3O plus is hydronium. So we may say pH is negative log of hydronium concentration. For some textbook, you may find another equation for pH. This equation is going to be like this. pH is negative log H plus. Both equations are same. They represent acidic solution because H3O plus based on Bronsted-Lowry theory and H plus based on the Arrhenius theory represent acidic solution. Some textbook in the literature, they prefer to use this one because it's going to be easier to understand. H represent acid, but most authors prefer to have pH is same as negative log H3O plus hydronium concentration. For our class, I'm going to continue by the first group when we have like this one. So whenever we are going to work on the pH, we need to remember this example. First, let me give you one example for this one. Question says, what is the pH? What is the pH of a solution with hydronium concentration, for example, 2.4 times 10 to negative fifth molar. So we are going to solve this one. What is the pH for this solution? So let me write that one. What is the pH for this solution? So when we are going to solve this one, we say pH is negative log hydronium concentration. We do have hydronium concentration here. So just need to plug in the equation. Negative log 2.4 times 10 to negative 5. So we need to find a number with no unit and report it here. So I'm going to ask you to calculate that. You need to know how to use your calculator to have the exponents and then apply this logarithm function. Then negative should be multiplied by your final answer. I'm going to report my answer as 4.62. I'm going to report my answer by this number. I'm gonna talk about the sigfig rules. The sigfig rules is going to be like this one. The number of sigfigs for concentration, it should be same as the number of decimal places of pH. This is the sigfig rule we need to know for pH and concentration, including hydronium concentration. So we are going to check what does that mean when we say like this one. Look here, it says number of sigfigs of concentration. This is the concentration of hydronium ion. The number of sigfigs, I just need to count. We have two sigfigs. We have two sigfigs. When we have two sigfigs, we need to apply the same number of sigfig as decimal places. So when we are going to apply for pH, 2 sigfig should be changed to 2 decimal places. I'm going to report by 2 decimal places. So please understand, if you are going to have 2 sigfigs, you are going to end by 2 decimal places for pH. Let me give it you one more example to understand this question. Question it says, let me write like this one. What is the pH? What is the pH of a solution with hydronium concentration? And let me give it you the number that it's going to be a bit different. 1.5 times 10 to negative 7 molar. Before solving the problem, I'm going to apply the sigfig rules. The number of sigfig is 2. So it would be the same as number of decimal places. So I need to report my final answer by 2. So I'm going to write pH is negative log hydronium concentration, negative log 1.5 times 10 to negative 7. and if I'm going to calculate that, it gives me 6.82. So I'm going to report by 2 decimal places because I have 2 sig figs here. If we have different numbers, absolutely we have to go with a different one. So I'm sure you understood that one. Question says, what is the pH if hydronium concentration is going to be like this one, 1.00 times 10 to negative 3. So I'm going to report that one. You just need to say, here in this example, I have 3 sig figs. I have 3 sig figs. So the number of sig fig is 3. So I'm going to report 3 decimal places. I'm going to report 3 decimal places. So I'm going to report the pH for this one. If you are going to report like this, when you plug in the equation, you should end to like this number. You may get 3 by your calculator, but you need to remember that we need to have 3 sig figs. So I'm going to have 3 sig figs here. I'm going to apply 3 decimal places. 1, 2, 3. So we are going to report our answer by 3 decimal places. So the number of sig figs is 3. So decimal places must be 3. So please keep in mind this rule. Right now, assume that we are going to talk about pOH. Everything it would be same. What is the pOH formula? pOH equation, it would be similar to the pH. So I'm going to remind you, for pH we have negative log H3O plus concentration. So I'm going to write here for pOH, we write negative log OH minus concentration, hydroxide ion. So we call that P function. P function means negative log. If we have H, we have H3O plus. If we have OH, OH minus. That is why some scientists prefer to write pH is negative log H plus because it's going to have more, it makes more sense. So question like this, what is the pOH of a solution with OH1 negative is 1.000 times 10 to negative 9 molar. So I am going to check the sig fig rules but with you guys. pOH is negative log OH minus concentration. I ask you to calculate by your calculator. So we don't have any unit for pOH as well. If you use your calculator, you get this number, 9. But we are going to review that one, the sig fig rules. Here in our concentration, we have 4 sig figs. We have 4 sig figs. So let me mark that one. We have 4 sig figs. So we need to have 4 decimal places. So 4 decimal places. 1, 2, 3, 4. So we are going to have like 9.000. Please keep in mind when we talk about the pOH is only a number in the theory, but pH has application in the chemistry. We have pH meter and we are going to use electrode to put in the solution and get the numbers. So everything is going to be for pH. But besides of the pH application, we wanted to show you how pOH is going to be similar to pOH. Relationship between pH and pOH is going to be like this. pH plus pOH is going to be 14.00. The reason we have like this because we have auto ionization of water, and we are going to end to H plus concentration times hydroxide concentration is equal to 1.0 times 10 to negative 14. It would be same if we are going to say hydronium concentration times hydroxide concentration is 1.0 times 10 to negative 14. You can easily apply the negative log to both sides of this reaction, this equation, and end to this equation. pH and pOH are going to make 14. If I'm gonna work on this some basic example, I'm gonna say, what is the pH of a solution if OH minus concentration is like this number, 7.2 times 10 to negative 4 molar. So I'm going to solve this problem. I'm going to solve this problem. Let me write this one, 7.2 times 10 to negative 9 molar. So I'm gonna make sure that you know that this is the meaning of this problem. We have different methods to solve this problem. I'm going to recommend you this method. I don't want to review the other methods. For the other methods, you can get the same answer like me. But this is the recommended method. If you have OH minus concentration, you can calculate pH. Sorry, you can calculate pOH. When you have OH minus concentration, you can calculate pOH. When you have pOH, based on this equation, you can get the pH. So this is the strategy I ask you to please apply. So we have OH minus concentration. I write pOH is negative log OH minus concentration, hydroxide ion, negative log 7.2 times 10 to negative 9. I need to calculate this. If you calculate this, you get like this number, 8.14. 8.14. So pOH is 8.14. But question says, what is the pH? I'm going to just subtract this number from 14. So I'm going to write the equation pH plus pOH is 14.00, and pH is going to be calculated 14 minus 14.00 minus 18.14. So pH is going to be like this number. Like this number. Please look here. We are going to talk about the pH. So that is why I just apply two different equations. Another method, you are going to have the same answer, but I do recommend you this one because you know how to calculate the pH or pOH and you know how to subtract from 14. So this is the easiest method you may have to solve the problems regarding this type of question. Let me give it to you another one. Let me give it to you another example. What is the pOH of a solution if hydronium concentration is reported like this number? What number would you like to have? I'm gonna say 3.2 times 10 to negative 9. I give it to 9, so let me give it to you 6 molar. Question mark. I ask you please pause this video, solve the problem, and then back here and double check. The strategy I'm going to apply is like this. We have hydronium concentration. So when you have hydronium concentration, you can easily calculate pH. When you have pH, then you can apply pOH. I'm gonna write pH is negative log of this ion, hydronium ion. As you see here in all of my video, I prefer to write the equation and plug in the equation to make sure when you are going to solve your problem, you have the same strategy like me, and it's going to get you the best practice part for each equation. I'm gonna write the answer here. It's going to be 5.4948, for example. I ended by this one. Right now, I'm gonna say that we had two suffix here, so our pH needs to have two decimal places. So I'm gonna keep two decimal places here. This digit is 4, I just need to drop it. So this answer is 5.49. So this is the pH. But question says, what is the pOH? I'm going to write pH plus pOH is going to be 14. So pOH is going to be calculated based on this number. And again, please keep in mind when we are going to report pH and pOH, we don't need to use any unit. They are unitless number. So I'm going to write pOH here 8.51. Again, two suffix at the beginning, it means our final answer needs to have two decimal places for pH or pOHs. Right now, let me work on another types of problem. Assume that we have pH, we have pH, and we want to calculate H3O plus. The equation is pH is negative log hydronium concentration. So it says pH is given and we are going to know what is the hydronium concentration. We have pH and we want to calculate hydronium concentration. I'm sure you are good in math and you can easily apply the anti-log to solve this problem. But if in case you are going to use another equation, I say that you can calculate hydronium concentration based on this equation, 10 to negative pH. So let me write that 10 to negative pH. What does that mean? Question says, what is the hydronium concentration if pH is 3.0? And let me write question mark, it's better. What is the hydronium concentration if pH is 3? So I'm gonna write the equation that we know that pH is negative log hydronium concentration. So pH is 3, negative log hydronium concentration. So you just need to apply anti-log to solve this problem. If you don't know that, and you are stop here, I may ask you to use this equation. Easy to follow. Hydronium concentration is 10 to negative pH. So I'm gonna write 10 to negative pH. pH is 3.0. I'm gonna report this number. I'm going to report this number. You need to press enter on your calculator. You just need to hit the enter button to get the correct answer. Let me solve this problem correctly to make sure you have the same answer like me. I'm gonna write the answer here. 1 times 10 to negative 3. So it looks as the answer for this one. Or you are going to have 0.001. right now I'm going to check. I'm going to check the sigfic rules. For our pH, for our pH, we need to apply the sigfic rules here. The sigfic rule is 1 decimal place for pH. 1 decimal place for the pH. When you have 1 decimal place for pH, it means we should apply 1 sigfig for our concentration. Again, I'm going to write the rule here. Sigfig of concentration, it would be same as the number of decimal places for pH. Please look here. Our pH has 1 decimal place. 1, this number is 1. It means we need to report 1 sigfig for concentration. I'm gonna report 1 sigfig for concentration. So this number is going to be the correct answer. 1 times 10 to negative 3 or 0.001 1,000th. Unit for concentration is molar. So I'm going to report by molar. Let me solve another example here. So question says, what is the hydronium concentration if pH is 2.85? Question mark. So question is pH negative log hydronium concentration. If you know how to rearrange the equation and apply anti-log for this, 2.85 negative log hydronium concentration, you can keep continue to get the answer. But if you don't know, this is the equation. Hydronium concentration, it would be 10 to negative pH. I'm going to apply that one. 10 to negative 2.85. But you cannot leave the answer here. You need to continue. What is this number? You need to calculate that. So please use your calculator to answer this question. My calculator gave me like this number, 0.00141253, and it's going to continue. So right now this is the time to apply the sigfig rule. First, I have pH. Decimal places of pH is 2 decimal places. It means I have to apply 2 sigfigs. I need to apply 2 sigfigs. So right now, 2 sigfigs. The zeros at the beginning, they are not sigfig. So this digit should be dropped. I'm going to end to 0.0014. Unit is molar. Or you may report that one as a scientific notation. As a scientific notation, you are going to end to like this one. So either this number or that number, they are going to be the correct answer for this question. 1.4 times 10 to negative third molar. And to remind you, if we are going to calculate the hydroxide concentration is 10 to negative pOH. So everything, it would be same like the problem I solved that one here. I'm gonna write the formula here. We have one formula, pH is negative log hydronium concentration. Similar to this one is pOH is negative log hydroxide concentration. Here we use this information when we are going to calculate pH or we are going to calculate pOH. Also, this is a relationship between pH and pOH. So this is this equation. pH plus pOH is 14. So if you don't have a direct ion like hydronium to calculate pH, you don't have hydroxide to calculate pOH. So you may apply this equation to get the answer as well. Another types of equation, when we are going to calculate hydronium concentration or hydroxide concentration, 10 to negative pH, and this one is going to be OH minus hydroxide ion 10 to negative pOH. When we use these two, whenever we are going to want to calculate concentration question mark. So right now I'm gonna say that I categorized these equations for different application. And on top of them, we have this rule. The number of sig of concentration, it should be same as the number of decimal places for pH. In case you need to have more practice problem, please watch this video one more time, pause the video, solve the problems, and then you resume the video and get the answer like me. Also, you have several solved problems on your textbook as well. Hope this video helps you to understand the meaning of pH equations in chemistry. Thank you for watching this video.